Hello everyone, this is KP the Math G. We're ready to do another video. Now, don't let this date fool you. I know it says 1998, but I say, well, those were probably easier then. Oh no. If you look at this, you can go down each year, you will find similar problems to this, although I have to say the first part of this problem is relatively easy. I want to say there are 4 parts to this problem. It's 1998 free response question number 4. Let's see, 1998, well, I was pretty old then, almost 40 then. Okay. Yeah. All right. Anyway, let's begin the problem. Let's not talk about my age. F is a function. I have to, since my board is kind of small, I have to kind of improvise with the questioning here. So it said let F be a function. So F is a function with F at 1 being equal to 4. The slope is 3x squared plus 1 over 2y. Alright, now find the slope of F where x is 1. Now this is likely the slope of the tangent line. Let me check that out. And it just says find the slope of the graph of F at the point where x equals 1. So so we're going to find the slope, and it is the slope of the tangent line. And although it doesn't say tangent line, it is the slope of the tangent line to that curve. Okay. All right. So let's go ahead and figure out what this slope is. Let's see. I want to try to get a different color here. See, I got blue, so let's try this color here. Alright, so the first inclination is to try to find the derivative of this. Well, when you look at this very carefully, I had to look at that. Well, the slope is, this represents the slope. Well, that's easy enough. M is equal to 3x squared plus 1 over 2y. Now, all I got to do is, I know that F at 1 is 4, so M is equal to 3 times 1 squared plus 1 over 2 times 4. Yep. And so 1 squared is 1, 3 times 1 is 3, 3 plus 1 is 4, 2 times 4 is 8, 4 over 8 is 1/2. So the slope M is 1/2. Okay. It says write an equation for the tangent line of F at x equals 1. Approximate F at 1.2. Alright, so we have to write an equation, alright, of the tangent line. Alright, so of the tangent line, that would be y minus y1 is equal to m times x minus x1. Well, I know what y is, and I know what x is, and I know what m is. Alright, so y minus y1 is, well, what's y1? That's the y right there. So y minus 4, so y minus 4 equals 1/2 times x minus 1. Now, I think for some of you, if you write this out just like this, okay, then you have everything you need here. Don't make a mistake and say -4 on this side when it's already -4 on this side. I know, just once you get it there, you're there. I'm going to go ahead and add 4 to both sides, though. I'm going to do that. So plus 4. So y is equal to 1/2 x minus 1 plus 4. And I didn't need to do that, of course, and I just told you once you get there you don't have to do that, but it's okay if you do or don't. I mean, you know, just be careful when you bring this minus over to the other side. You know, some people get the point and then they lose the point when they make a mistake here. Okay. Alright, so now we got approximated at F at, and then this is F, okay. Y is F at X, so keep that in mind. Alright, so F at 1.2, okay, is equal to 1/2 times 1.2 minus 1 plus 4. Let me flip the board over just a little bit and then we'll finish the problem that way. I have a tendency to crowd everything up and I don't want to do that. So 1/2, okay, 1/2 1.2 minus 1 plus 4. Okay, here we go. Alright, so F at 1.2 is equal to what did I say it was? Let me look back again. I know I have a short memory. 1/2, okay, so we knew what the slope was. 1/2 times 1.2 minus 1 plus 4. There it is. Alright, and then 1/2 times, okay, now if I take 1.2 minus 1, isn't that going to be 0.2? Alright, plus 4, like that. 0.2 is 1/10, or 2/10, right? Okay. 1.2 minus 1 is oh, wait a minute. Yep, 0.2, isn't it? I do believe I'm right. I don't know why I'm second guessing myself on that one. Alright, so 1/2 times, I like to say 2/10. 2/10 plus 4. Yeah, the 2's will cancel out, and you don't even have to make that 1/5. Alright, so this is 1/10 plus 4, which is, I can multiply 4 times 10 and get 40. 40 over 10, that's still 4, isn't it? Just learn to do that. 10 times 4, see, 10 times 4 is 40, and then just put it over 10. And that is 41 over 10, which is equal to 4.1. I believe the answer they show is, I know the answer that they show is it's written like this. Probably if you left it as 41 over 10, you would be okay with that too. Alright, so that is how to approximate. Just make sure you understand how to, find the tangent line. Y minus y1 equals m times x minus x1. Let's go a little further than this. We might have a little time. My wife is cooking dinner tonight, and so I'm going to make an attempt to probably do another part of this problem. Okay. Let's go ahead and I just want to erase this. Alright, I'll just leave everything on this side of the board here. I don't want to flip the board over. Alright, there we go. Alright, nice. Okay. Okay, now let's see what the third part is. And I didn't really prepare to do a third part. I just thought maybe these first two would be okay. Alright, so we want to find, it says find f at x. Alright, let's see, by solving the differential equation. Alright, so we'll just go ahead and say what it is. dy over dx is equal to 3x squared plus 1 over 2y. That was, remember, that was the slope problem. So we're going to find the definite integral of this, but this is separation of variables. You recognize it's separation of variables, right? All right, so and we do have an initial condition. Let's see. All right, the initial condition, I'm just going to abbreviate this. Initial condition is f at 1, as we saw from the last example, is equal to 4. Okay. All right, a little work to do, but this is not too bad. All right, again, I'm going to write the problem here down. dy over dx is equal to 3x squared plus 1 over 2y. Now I'm going to multiply both sides by dx. This by dx, and this divides out here. So now I'm left with 2y is equal to all of this, 3x squared plus 1 over 2y dx. I can get this 2y on the other side simply by multiplying both sides by 2y. Alright, if I want to put it over 1, I can. Alright, over 1, okay. So now what we have here is 2y dy is equal to 3x squared. These are gone. So 3x squared plus 1 dx. Alright, like that. And remember, once you separate those, now you have to, we're looking for an equation, so we have to take an interval. Alright, so I'm going to separate that 2 over here, put it over here, and just make that there. And I'm going to, let me erase this equal sign a little bit, and I'm going to integrate both sides. Okay, remember that's how we do when we're doing separation of variables. Okay, we're not dealing with a definite integral. We already have an initial condition, f at 1 equals 4. We'll see why in just a moment here. But it's easy now to integrate this side and this side, isn't it? Right? Okay, so let's see. Let me erase some of this up here. Alright, I don't need this up here anymore. I'm going to try to put it all on this side right here. Okay, so let's see, 2 integrating y dy, we know what that is, and then we're going to integrate 3x squared plus 1, okay, 3x squared plus 1 dx. Alright, now again, this is 2 times y squared over 2. Alright, remember, just add 1 to the exponent and then divide by that same thing. We already know that the 2's are going to divide out. Okay, right here, this is going to be 3x cubed over 3 plus x and plus c. Alright, so we don't need the parentheses here. I don't know why I'm doing that. So remember, don't forget this. If you leave off the c here, problem over. They don't look any further than that. If you leave this part off, they'll give you credit down to where you got the integration part correct. And I don't know how many points that is really. Let me look. I think I have it right here. 1 point for separating variables, 1 point for the antiderivative of the dy term, 1 point for the antiderivative of the dx term. Uses y equals 4 and x equals 1 to pick one function out of a family of functions. Solves for y. But now, if there's no c here, there's a few points left off here. So yeah. Alright. Well, we have to put that c there. I forget how many points are lost there. But now look here. This is just y squared. Okay, let's put it all right here. is equal to x cubed plus x plus c. And now, I mean, if you want to solve for y, solve for y, you can take the square root of both sides like this. Okay, well, you don't even have to do that right now. You can go ahead and find c if you want to. Let's do that. We can do that, and then, okay, it does not matter. We could have done this already, but this is okay. Let's leave it like that. Y squared. Now y, now remember, this is like x, and here's y. Okay, it's just like that ordered pair right there. It's on that point right there. Alright, so 4 squared is equal to 1 cubed plus 1 plus c, and 16 is equal to, well, 1 cubed is 1, 1 plus 1, so 1 plus 1 plus c. So 16 is equal to 2 plus c, and then subtract 2 on both sides. So we know that c is equal to 14. So back up to this now, we're down to y squared is equal to x cubed plus x. Now the c is 14. Alright, now to solve this, we take the square root of both sides. Got a little sloppy with that, sorry. Alright, now usually when you take a square root of both sides, like if you have x squared is equal to 16, you take the square root of both sides, usually x is equal to plus or minus 4. Well, we're not dealing with the minus sign. Why are we ignoring, I had to learn this, why are we ignoring the minus sign? Okay. Why are we ignoring the negative sign? It's only the plus one, not the negative. If you look at right here, this is y, and y is positive. If this has been a negative 4, you're going to take y to be negative. But since 4 is positive, you're going to keep this sign positive right here. Okay? And of course, there is one more part to this that says evaluate this at 1.2 again. I will say this, you do get an answer very close to 4. Let's see, what was it? Well, I didn't evaluate that. Okay, I don't think I did. Oh yeah, I did on the other side. Hold on, sorry. Oh, hey.
About ready for dinner?
Yeah, I'm ready for dinner. Yeah. I don't see it on this side. Let me look at it on this other side. I thought maybe I've already done that. Okay, so let's see here. 1/2 times 1.2 minus 1 is 0.2. 0.2 plus 4. Okay, and then 1/2 times 2/10. Oh yeah, we did. It's 41 over 4 plus 4. That's 41 over 40 rather, which is over 10. I think over 10, yes. Over 10, which is 4.1. And then I think the final answer, if you plug that in, if you plug the 1.2 in to this problem right here, believe it or not, you will get 4.1 something. Very close. It's pretty interesting there. But anyway, I just want to leave it at that then, because I don't want to spend too much time. This is 3 parts to this problem. I think this will do good right here. But then again, you got to remember, you have to separate the variables. You have to integrate both sides. You have to put that plus c on the end, and then plug in the numbers to find out what the value of c is, and then y squared, the plus sign, because the y is already positive. Okay. Alright, that's all you have to do. That's pretty much it on this one right here. Yeah, this was I felt like it was a fairly simple problem in some areas, but some students again leave off that plus C, and if you do that, you're not going to know what to do from here. Okay, but anyway, again, hit that subscribe button if you haven't subscribed already. You feel free to make a comment if you like to. My wife has already told me it's time to eat dinner. So this is KP the Math G signing off. Have a great day.